Albert I.O. is due every Monday at midnight. So if you have not done your Albert I.O., put a reminder in your phone or something. Those easy points, guys. You can do it late, up to a week late for half credit, but why get half credit when you can get full credit without any stress in your life? Truthfully, yes. I mean, the math teacher in me doesn't want me to tell you to just fill it out, but I do pick questions that are good, that go with what we're doing. I don't pick just random questions, and they are SAT level questions. So if you are trying to do better on the SAT, it helps you learn this stuff, then that's a great way of doing it. But bottom line is, it's not for a grade, except for completion. Okay? It's something I'm required to make you do, which I don't always agree with sometimes. So I try to make it worth your while, and I'm doing my job too. All right, also, there's 2 quizzes we've had so far this 9 weeks. We had one 2 weeks ago that was 3.3 open note quiz, okay? So 2 weeks ago, and there's still a few of you that have not taken it. Then on Friday, we had 3.6 not open note quiz, okay? Both of those quizzes need to be made up by Friday, okay? There are some of you that waited the entire quarter last quarter because I was nice about it and then never made them up. So if you owe me 3.3, look in the computer if you weren't here, if you don't remember. There's only like 2 or 3 of you. And if you weren't here Friday or you didn't take the quiz on Friday, make sure you see me after notes any day. You could start your quiz then. Or if you want to stay during lunch, go get your food, come back. That's fine too. Right? I will work with you on when it gets done, but I don't want you to miss the new material either. When you take a quiz, even like a makeup, I am going to have you put your phone up though, okay? So I'm not really watching you. Okay, so look at what the title is. Graphing quadratic inequalities. That's the new part, okay? So if you will remember how to graph the quadratics that I go over with you, that part that makes it an inequality involves some shading. Remember like less than and greater than, like you shade above and below? Same idea, but with a smiley or a frowny, a quadratic, okay? And it's really, really simple. It's just we have to remember how to do the graphing part. So standard form, we've seen it a million times, okay? AX squared plus BX plus C, right? We've done quadratic formula with it. We've done our chart factoring. We've graphed. We're back to graphing, okay? And what I want you guys to remember is that so inequalities, whenever you have a solid equal to sign under your less than or greater than, you graph with a solid line. If you don't have an equal to sign under it, what kind of line would it be? Dotted, okay? That's what we've learned before. Here it is again. So that's one thing that's different with just a plain old quadratic. And I want to remind you that if you have less than or equal to, so bottom line is less than, we shade where? Above or below?
Below.
Below. Less than is like lower. Less, lower, below. Okay? So greater than or equal to, we would shade above. Good job, JT. All right? So those are some reminders. So let's pretend we're back in section 3.1, where these are equal signs instead of less than or equal to or less than. Okay, how would we have graphed it? And there was a little itty bitty baby infant formula that you needed to remember to be able to graph when you're in standard form. And that starts with finding the vertex. Anybody remember that formula? Negative b over 2a. That's right. To find the x value of the vertex, it's negative b over 2a. Okay? That's what we're going to do. So, and I don't require you to write what A, B, and C are. I like to do it to organize my information. We should all be able to identify A, B, and C at this point. We do it almost every day in here. All right, so let's just plug right into negative b over 2a. So we have negative b. Could I have skipped that step and just made a minus and a negative, 2 negatives, a positive? Of course you could have, okay? But it's negative 2 over 2 times a. And like we said, negative and a negative become a positive. You get 1. Okay? So what we just found is that the x value of our vertex is 1. That's what we just found. And that's the most amount of like work we have to do, arithmetic, because now we just go to our calculators, and I would clear the RAM, because my pre-calc kids are doing some crazy stuff right now. So if you want to clear your RAM, second plus 7, 1, 2, get your they've changed the settings in there. So clear your RAM. Everybody know how to clear their RAM? Because I see people not picking up their calculators. Second. Oh, really? Okay. Okay, just put it to the side. Sam, can you hand him that one? Yeah, and Gabriel, remind me to make sure I grab it from you. Okay, so second plus 7, 1, 2. Paris, did you do that? And then we're going to go to y equals, and we just type that in. Don't worry about the less than or equal to. Just type in your x squared, and so on, minus 2x plus 8. And by the way, I'm still in the process of grading your quizzes. I'll have them graded during lunch unless something crazy happens. Okay, so I just typed that in, and then do you guys remember where you go to see what we need? Table. Yeah, second table. So it's second, because table's blue, above graph, and that gives you your table of values. We want to find 1. Oh, there it is. That means my vertex is 1, 7. And then remember, we did an XY chart, but we don't have to do any work here, guys. We just steal it from right here. You can either use 1 and 2, or -1 and, you can either use 2 and 3, So we're at 1. You can either use 2 and 3, or 0 and -1. It doesn't matter. Either set, because you're going to have the same numbers as the y values. So if I use 2, I get 8. If I use 3, I get 11. Same y values I would get if I use 0 and -1. Okay? Now I have everything I need to graph. So I'm going to the right 1, up 7, right 2, up 8, right 3, up 11. I'm all in quadrant 1 here. So instead of using up a whole bunch of graph paper, I can nice and easily kind of just skew my paper, skew my graph. So I'm only using like a lot of that. And you don't waste a lot of paper. I mean, it's no big deal if you do, right? But it's just nice to kind of squeeze more problems on a sheet of paper. So my graph is going to be to the right 1, up 7. 1, 2, 3, 4, 5. And that's going to be it. I always like to make my vertex an X. And then 2, 8, 3, 11. Now, I'm not making you identify the axis of symmetry and all that, but it's helpful because you know that there is an axis of symmetry that goes right through the middle that helps us graph the other side of our quadratic. Right? So you can see the outline of my parabola right there, and it's an equal to underneath it, so I'm going to make it solid. Okay? If it didn't have it, we would have made it dotted. And then the only thing that's really new here, guys, is where do I shade? This is less than. So I have to figure out where I'm going to shade that's less than, below my parabola. There's only 2 places you can do. On the outside of it or on the inside of it. And it goes on forever. So do you think that less than is going to be, watch my pencil, out here, so this choice, or inside? On the outside. Think about where your points are going to be less than. All outside of the graph. And it goes on forever. So this graph goes up forever, and always on the outside of that parabola, that would be less than. Okay? If you went here, you'd be going up, 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 up. Even though you're going up here, you're staying on the outside of it, so you're always less than. That's the only new part. Okay? Let's do one more, and then I'll do a couple with you on your homework too. And I said up at the top when I wrote the assignment down, I added this section in. I had missed it when I did my planning originally, so I didn't have you guys rip this out. But I don't want you guys feeling you have to go and rip it out. It's only 5 problems, and they all fit on one sheet of paper in my piece, so you can easily just grab them from my piece. Okay, so let's identify what we have here. We only have 2 numbers. We should know at this stage of this class which one's A, which one's B, which one's C, which one is being left out. What letter do we not have? C, because it's the number that has no letter. It's called a constant, right? The number in front of x squared is our A. The number in front of the x is our B. So C b is the constant, and there's nothing there. So it's nothing in math means 0. Although we don't really need it, right? Negative b over 2a. We don't really use c for this, but it's good to know for other problems. Okay, so x equals negative b over 2a. Yuck. You get a decimal. That's 1.25. That's okay. We're using a calculator. The calculator does the hard work for us, guys. Vertex would be 1.25 is the x, and I am going to use my calculator to find all the rest of the information. Okay? So when you go back up to y equals, clear it out. You can clear your RAM if you want to, but you can just hit clear right here. Type in what we have. Negative 2x squared plus 5x. Okay. And you can graph it, but we don't really need the graph. The graph is good to see if we graphed it right, maybe later, but what we really care about is the table. Now remember, the table defaults to counting by ones. Okay? What would we rather our table count by so we can find 1.25? 0.25. And you see right down here, it's highlighted. Press plus for change in table. That's what that triangle means. We want to change the table to count by something else. So that's like a quick button to get to. So if you hit the plus button, it's asking you, what do you want to do? Right now it's counting by ones. And like Gabriel said, we're going to say 0.25. That way it'll do every 0.25 increment because we want to know what it is at 1.25. And when you hit enter, then you can see them all. Find what we want to be at right there, right? Find positive 0.25. No, I'm sorry, 1.25. Sorry. Keep going with it. So 1.25, I mean, we don't like dealing with decimals or fractions, but this is too easy for us to think this is hard, right? Your calculator does it for you. And you will be able to use your calculator on every test, every exam I give. There's no county test or anything. It's me. So you can trust me that you're allowed to use your calculator for this. You can use your calculator on the SAT, too. You can use one of these on the SAT. Okay, so that's the vertex, right? We need 2 more points, okay? You can stay in decimal land if you want to, but I would rather just use whole numbers. Okay, so totally fine if you want to do like 1.5 and 1.75, but that's yucky. They're really small decimals. So you're not wrong to do that. I want to go back to whole numbers, or I already know what the whole numbers are, right? Like if I pick the next 2 whole numbers, it'd be 2 and 3. And instead of taking all the time to change the table, I can go find. 2 would be 2, and keep scrolling till you get to 3 would be negative 3, okay? But if you wanted to change the table, it's under table set. So it's blue, table set. And see how I did change in table as 0.25? You could change it back to 1 if you wanted to, right there. And then go back over to your table and you can, oops, what did I do wrong? Table, start at 1, and then table. So there you can see 2, 2, 3, negative. But like I showed you, you don't really have to change the table. Just find your whole numbers. Or just use decimals. It's just harder to graph. Okay? So I take a look. This is quadrant 1, and a little bit of quadrant 2, right? To the right 3, down 3. All right, so I'm going to just kind of give myself a little bit back. So the vertex is a decimal, and that's non-negotiable. I have to graph it exactly like it says. I mean, 1 1/4 to the right, 1 and a tiny bit, like right here maybe, and then up 1, 2, 3, and a little bit, maybe right there. It's not going to be perfect. But that's why I didn't want to do decimals here. This part at least would be easy. Right 2, up 2, right 3, down 3. And then you can go right over your axis of symmetry, so be here, and then things like around there. Now, don't be careful, be careful, be careful. This one would be dotted, right? Dotted. zeros on the ends. And it makes sense that it's opening down, right? We have an A value that's negative. When A is negative, negative people frown, so it's always going to open down. Where do you think less than is? Do you think it's inside or on the outside? In. Yeah, the numbers that are less than would be inside. And it goes on forever and ever and ever. All right. If you're in doubt, there is something you do. If that part right there is confusing to you, pick a point. The easiest point on any graph is 0, 0, right? So if I did a test point, now this is optional, but look, for some of you, I saw some of you kind of had questioning looks with the inside. For some of you, you see it just depends on how we learn things. If you typed in 0, 0 into this problem, would it make it a true answer? So 0 is less than, and when I plug in 0 here, I get 0. Is that true? Is 0 squared from 0? Is 0 less than 0? That something doesn't seem right with that. It should be not true. Is 0 less than 0? Because it's in our test area. I think it doesn't matter if it says less than or equal to. Okay, so is 0, 0 a point inside here? Yes. Does it make this true? Whether it says, because that just has to do with the dotted or solid. So 0 is less than or equal to 0. So it is a true statement. Look, if you plugged in 0, 0 here, it should also make the left side equal the right side. Okay, because it's in our shaded area. If it's not, like if 0, 0 had been in this part of my graph or outside of the graph, it should not be true on both sides. Okay. All right. So let's go to the homework. And I know you guys I don't think I had you guys rip out this page. That's my fault. But I'm telling you, you don't need to. Okay. There's only 5 problems. I'm going to do the first 2 with you, and the other 3 are done as well. So you can just copy the problems down from my paper if you want to. So let's get ready to do I'm going to do the first 2 with you. Everybody ready? And again, that's optional. And then we'll plug into our little formula that you do need to know. So we have a vertex of -3 something. Right? So if I were you, I would clear your RAM, because right now you have your calculator table set to 0.25. Unless you changed it already, it's going to stay that way. So when you clear your RAM, it changes anything, all the settings you might have changed, it takes it back to normal. Okay? So I'd like to clear my RAM a lot. Y equals x squared plus 6x, x squared, don't forget to come down off the exponent, plus 6x plus 4. I mean, and like I said, you can look at the graph, but you can't get your points from that. The only reason that would be helpful is to make sure when you're done, your graph looks like the actual graph. What we really want is the table. And we need to get to -3. So I'm scrolling up to get to -3. And I can see the rest of my vertex is, I think that says -5, right? Is that what that says, guys? -5. Okay, thank you. All right, let's grab 2 more points in either direction. It doesn't matter, because the y values are the same. I'll use like -2 and -1. Again, stole it from my calculator. Stole it. All of these points are in quadrant 3, to the left and down. So I only gave myself a very small amount of space, so I'm going to make sure I use it properly. Okay, so 1, 2, 3, 1, 2, 3, 4, 5. There's my vertex. Back to 0, 0, left 2, down 4, back to 0, 0, left 1, down 1. We know about that axis of symmetry that helps us graph the other half of our parabola. That's going to be solid, right? Solid. And less than or equal to. Are we going to be inside the parabola or outside the parabola? Outside. And then. So remember the negative in front of a number, you keep it with it. So that's negative 1, positive 4, negative 6. X equals negative b over 2a. So my vertex is going to be 2 something. 2 times negative 1 is negative 2, and a negative divided by negative is positive. So I'm going to go back up to y equals clear and type this one in. Negative x squared, come down, plus 4x minus 6. Go to my table, and I want to find 2. There it is. So my vertex is 2, negative 2. Pick a couple x values on either side. I'm going to use 1 and 0, just because I want to. Negative 3, negative 6. So I could have used 3 and 4, 1 or 0. The y values would have been the same. Okay? So to the right and down, I'm mostly in quadrant 4 here, to the right and then down, so I'm just going to draw my graph. And I have to go down 6, so I need to make sure I give myself plenty of room to be able to go down that far. Okay? So to the right 2, down 2, there's that vertex. 1, negative 3, and 0, negative 6. Reflect across the axis of symmetry. And it's opening down. Should it be? If you're feeling like really unsure, remember you can just hit graph. If you hit the graph button, you'll see that our graph matches that graph. That's really the only thing that's helpful for. Okay, less than. Oops, it should be dotted. See, I messed up. Happens all the time. Just write me a note. You don't need whiteout. You don't need a new piece of graph paper. Just telling me you knew it should have been dotted is good enough. Okay? Dotted because there's no equal to sign. Are we going to shade on the outside or inside? Inside. Because that lets us go really low, right? Stay right inside. Less than is on the inside. Well, if it's opening down, less than is on the inside, greater than. Like, think, it's because you can't do greater than in here. Where are the numbers that are greater than that? It's going to be up here, right? So by default, if this up all of these points, including all these, but especially these points, if these are greater than and we're less than, we only have one other choice. It's either going to be on the outside or the inside. So since it's not greater than, we know it has to be on the inside. So it's kind of like looking at the picture and seeing which one makes more sense. Okay, but I'll help you with that as you guys continue on. So there's 3 left for you guys to work on. I have done all the work. I don't just copy my work. You need to know how to use the calculators and how to find this stuff. This is for you to check your answers, not copy. I'm starting to see some people get done with their homework really quick, but not doing very well on quizzes. Okay? Way to own it, Karen. It intimidates you. Yeah, that's normal. Albert I.O., if you finish and you haven't done your Albert I.O., you need to do it. Get on your phone. You have it on your hand anyway. I haven't put it in. I will today. But yeah, every Monday I'll do a new one, and the old one is due.